Talukder from University of Calcutta, and my topic is let's ponder over polarization. So, as you can see it, this is a light source and this is a glass slab behind which I have written SPIE student chapter of University of Calcutta. Now, what happens is when the light falls on it, it gets reflected, right? Since this light is not polarized, so what happens? The electric vector of the light, it has two components. One is perpendicular, another is parallel. So, when the light falls at Brewster's angle, then the reflected light consists only the perpendicular component. Now, I have prepared a glass using polarizer. So, if you wear it with one eye closed, I can see the reflected light, and with another eye closed, I can see the writing SPIE. And so, why is it so? The reason behind it is, when the light falls at Brewster's angle and gets reflected, what happens? This polarizer, the axis of it is parallel to that of the reflected light. So what happens? This and this becomes cross, so the reflected light is not allowed to pass through it. And from the second thing, what happens? If we close this eye and view from this, the axis of it is parallel to the reflected light. As a result, it allows the light to pass through it, so we can see the reflected light instead of this SPIE student chapter. So this is the first model, and the second one is, now this is a glass slab and I have used cellotapes in order to make tree, house and mountains. So these two are polarizing sheets. Now if I keep this polarizing sheet behind it and if I rotate it, I can see different colors. So why are we seeing these different colors? Because the cellotapes used here are birefringent. So when I'm putting it and the light is passing through it, it's getting divided into O ray and E ray. As a result, when it is being rotated, these two components of a particular wavelength, they are being introduced a destructive interference. As a result, for that particular wavelength, we are seeing a black component, and the wavelength surrounding it, they get attenuated to some extent, and the other wavelengths, they remain unaffected. So the colors are coming from those wavelengths rather than that. So we can see different colors. So this is the second model, and the third model. We all know calculator, this is a regular stuff in every house. This is an LCD, and we know there is a polarizer on the top of it and a polarizer behind the LCD. What I have done is, I have removed the polarizer from the top. Now, even if I put it on, what happens? I cannot see anything, but things are getting written here. So what I have done, I have used this thing. You can try it, ma'am. I have used this thing. I have used polarizing sheet over here. So putting one eye closed at a time, see it. You can see black background and the white writing, and white background and the black writing. So why am I seeing it? Because the top polarizer and the bottom polarizer, they are at 135-degree angles and another is at 45-degree angles. So as I have removed the polarizer from above, I have placed the polarizing sheet here, one at 135-degree, another at 45-degree. So when the light is coming up, once we are seeing the black background and the white writing, and when it is doing reverse, we are seeing the white background and the black writing. So it's sort of a magic.